Okay, let me give you some more examples of proportionality. So again, I looked up on the internet. The surface area of a sphere is given by this here. Now let's say you're a manufacturer of footballs or soccer balls. The amount of material you would need, well, you would look at the surface area of a sphere to represent your amount of material needed to make one football. You wouldn't look at the volume of a sphere to represent the amount of material needed, because when you make a football, your material is really the thing that goes around on the thing that goes around the surface of a sphere. So your material, you see, this bit in the middle is just air. So it's not good to use a volume to represent the material needed to make your football. You would look at the surface area of a sphere to represent the material needed to make your football. Okay, so in this video we would investigate what would happen if let's say you want to make a bigger football here. Your company wants to make a bigger football where the radius is 2r. So if you double the radius, how will that affect the material needed to make your football? Okay, so start by looking at material. Hang on, material needed to make your football equals this, the surface area, because the surface area is a good representation of the material needed. So you start with this here. Okay, now visualize it as this equals well, 4 pi being stuck in a bubble timesing r squared. Okay, now because we are trying to investigate what would happen if you double the radius, so your football is 2r now. Okay, how would that affect the material needed? Well, we are varying the radius of the football. You see, r here changes, whereas 4, well, this here is a constant, the number 4. Pi is just a number, 3.1, 3.1 blah blah blah. It doesn't change. So 4 pi is just a constant, and it's a constant that we don't care about because we are just changing the radius. We are just investigating the change in the radius, not the, well, this bubble here is just a number that doesn't change, and we don't care about that number. So let's tidy up. Let's just say any number, okay, times the radius here, the radius squared. Okay, so material needed is some number times the radius squared. So this is our current football. So remember, our current football has a radius of 1. So it would be this. Okay, has a radius of 1. Now let's say we are trying to create a new football of twice the radius. We are trying to create a football of twice the radius. So now the radius will be 2r. Okay, so our new football, material needed for our new football, material needed for our new, let's call this new here. For our new football, let's call this old. Okay, so our old one is r squared. So the radius of the old one is just r here. Okay, but now our new football will have a radius of 2r. So we have to do this here. We have to do this. Hang on, k, and then this. Our new radius. Well, normally it's a number radius squared, but our new radius is 2r. Okay, this here is our new football here. Okay, now let's try and evaluate this bubble here. This bubble here. Let's try and evaluate this one. So what's 2r squared? 2r squared means you get whatever it is and then you times by itself. So 2 times 2 will be 4. R times r will be r squared. So so this thing here would equal k 4 r squared. Remember, we use the squared here to merge it. Well, we are using the square here to act on this 2r. So this whole thing here becomes this. Okay, so this is our well, it will now look like this. Okay, so now we are just move the, well, number always goes in front first. So let's put the number first. So it becomes 4k r squared. So this is material needed for a new football. Okay, this is new. Now, if you compare the old one, remember our old football has a radius of r. Our new football has a radius of 2r. Okay. Now look at old. Hang on. This here is our old one here. Now material needed for our old one is kr squared. The material needed for our new one is 4kr squared. You see, this kr squared here is exactly the same as this one here. So you see, our material needed for a new football would be 4 times the old one. 4 times the old. You see, this here is exactly the same as this here. So what it's saying is that the material needed for our new football is going to be 4 times the material needed for the old football, because this here is exactly the same as this here, and the material needed for a new football is 4 times the whatever the old one was. So doubling the radius. So in this case here, hang on. So in this case here, if you double the radius, the amount of material your company will need will be 4 times as much. Okay?